Hello coders, I welcome you all. Have you ever wondered how companies are building AI agents that can answer questions, send emails, search documents, take approvals, and automate complete business processes? The interesting part is that many of these systems can be built visually using n8n. Yes, using n8n without writing single line of code. In this masterclass, we will start from the basics using OpenAI models and then explore how to build similar AI applications using free models through OpenRouter. As we progress, we will learn AI agents with memory, RAG, vector databases, MCP, Guardrails, human in the loop, multi-agent systems, and AI evaluation, where we will understand how AI systems can automatically evaluate, measure, and improve the quality of their own outputs. Each section builds on the previous one, so I highly recommend following the course till the very end. So let's get started. Let's jump to n8n. So now let's discuss n8n. Let's start with a simple idea. Till now, most systems only respond. You ask something, they give an answer. But what if the system could actually complete the task for you? Not just answer, but also do the work. This is the exact idea behind Agentic AI. Agentic AI means a system that can understand, decide, and act automatically. Now, to make this happen, we need something more than just AI. We need a system that can connect different tools and perform actions. This is where n8n comes in. n8n is a simple workflow automation tool where you just drag and drop nodes that you can see on the screen. So as I said, n8n is a simple workflow automation tool where you just drag and drop nodes, connect them, and your task gets executed automatically. It is also helps us understand agentic AI in a clear and practical way before we start coding it using different frameworks and tools. So when we combine both, AI means LLM decides what to do and n8n actually performs those actions using tools. So LLM plus tools means simple agentic AI that you can see here. As you can see, here is our LLM and these are different tools, right? As I just said, LLM means AI decides what to do and n8n actually perform those tasks using different tools that you can see, right? So we will understand this clearly with hands-on examples in the practical sessions. But for you, let me execute it once. We will create this entire flow from scratch. Don't you worry, right? But just I want to show you. Let me ask, tell me today's date and time. Please look at here. As you can see, when chat message received, OpenAI node is executed. And out of these many tools, it used this particular tool, date and time. As simple as that, right? As I said, we will understand this clearly with hands-on examples in the practical sessions. But before that, let's create an n8n account first. So now that we have a basic idea, let's create our account on n8n. First, open your browser and search for n8n. Open this particular official website of n8n. On the top right, you can see Get Started. Let's click here. Now we have to enter our email address here. Let's press submit. And here you can see, click on the verification link sent to this particular email address. You will receive a verification code in your email. Just open your inbox and enter the code here. You can see I have received this particular code. Let's press submit. Now we need to fill some basic details. So I have entered my name, also set a password, and choose a workspace name that you can see, means account name. Let's click here, start free 14-day trial. So this is enough for our learning and practice. You may see a few simple questions. I will quickly select the options and move ahead. Press submit. Invite team members to your workspace. Let's skip this. Also, you can see n8n quick start tutorial by clicking over here. Now let's click on start automating. Let's click on workflow personal. That's it. Setup is done. Now we are ready to build something interesting. So now we are going to set up the tools and the LLM that our agentic AI system will use. These are the components that will help our system think and perform actions. The LLM. For that, we are going to use OpenAI. Will act as the brain, and the tools like Gmail, Google Sheets, and other will help in executing tasks. We will connect all of this with n8n. Don't worry about understanding everything right now. We will use each of them step by step during practical. Now, let's first set up OpenAI LLM, the brain. So here, search for OpenAI API. Click over here, API platform, start building API dashboard, and here I'm going to click this continue with Google. Here, two-step verification. Done. And after that, we have to click here, API keys. I have already created this. You can create from here. Create new secret key. But I'm going to use the same. After doing this, you have to save this particular secret key somewhere in your computer, right? Just we have created this particular API key. Now let's back workflow. Click here plus click on credential, personal, and here we have to search for OpenAI. Let's press continue. Now here we have to paste our API key that just we have saved, right? Copy and next. Paste it here. This is my OpenAI API key that just we have created, right? Keep other things as it is. Press this button, save. You can see credentials successfully created inside your personal space. Done. Now let's press escape key. You can see our OpenAI account has been connected with n8n. Next, we are going to set up PineCon, our vector database. Now, for that, we have to search for PineCon. And here is the official website of PineCon. Let's click here. You can see the home page of PineCon. First, we have to log in. Let's press this button, login. Done. Let's continue with Google. After that, you can see to our left side, API keys. As you can see, I have already created one API key for PineCon. But let's create new. Let's click here, API key. Let's give data thinkers. You can give any name. Let's click here, create key. You can see your data thinkers API key has been generated. We have to press this button, copy and close. Done. So you can see we have created API key on PineCon. Let's back to credentials on n8n, right? You know from here and personal. Now we have to search for PineCon API that you can see here. Let's click here. Let's press continue. And here paste that key that just we have copied. Done. Now we have to press this button, save. You can see done, right? Let's press escape key. Done. We have completed our second step. First is OpenAI account that we have created and PineCon account that we have created, right? And successfully connected this with n8n. You can see our LLM is ready to use with n8n, and also our vector database or our vector store ready to be used with n8n. Now let's set up Gmail. Again, press here, create credential, search for Gmail, and you can see Gmail OAuth2 API. Let's click here. Let's press continue. Here we have to sign in with Google. I'm going to use this particular account. Continue. You can see account connected. Let's press escape key. Let's check needs first setup. Again, let's click over here. Sign in with Google one more time. This particular account and press continue. Now I think done. Let's press escape. Great. You can see now Gmail account has been connected with n8n. Now let's set up Google Sheets, which is our next tool, right? Again, let's click over here, create credential, and search for seat. You can see Google Sheets OAuth2 API. Click here, continue. Again, sign in with Google. Same email I'm using, press continue. I think done. Let's press escape key. Again this, again here, again same account and continue. I think done. Again escape key. You can see done, right? Successfully connected, vector database, Gmail and Google Sheets as well. Now we are going to connect Google Drive. Again, create credential, search for Drive, Google Drive OAuth2 API. Let's click here, continue, sign in Google, select the account for that you want to share Google Drive. Again, I'm selecting the same account of Gmail. Continue, escape key, again needs for setup. Here, sign in Google, same account, Gmail account, and continue. Let's press escape. All done. So now everything is connected. LLM will make decisions. This one, OpenAI LLM, and these are tools to help n8n perform actions. Right? Let's move on. Now our setup is ready. Now we are going to build our first Agentic AI workflow inside n8n. I will create it step by step and you can follow along with me. Click over here, plus workflow and personal. As you can see here, two options. Add first step, build with AI. Let's click on add first step and you can see here what triggers this workflow. First, search for AI agent. Let's click over here. We are keeping all these parameters and settings as it is. Let's press escape key. Done. You can see n8n automatically adds two things. A trigger, this one means chat message, and the AI agent node that you can see here. Whenever we send a message, the agent will start working. Now the agent needs a brain. So let's click on the plus button. Here you can see chat model. Click here, this particular plus button. Again, search for OpenAI chat model. Let's click here. Here you can select different chat models from OpenAI, but I am keeping this particular default GPT-5-mini. Press escape key. Done. You can see our chat model has been added to our workflow. Now our agent can think. Next, let's give tools to our agent. Here you can see tool. Let's click on this plus button. Let's add our first tool, Wikipedia. Let's keep as it is. Let's press escape key. Done. You can see our first tool has been added to our workflow. Let's add one more tool, date and time tool. Click here. Let's keep as it is these parameters and settings. At this time, let's press escape key. You can see our next tool has been added to our workflow. Add one more tool, calculator tool. Again, we are keeping parameters and settings as it is. Let's press escape key. You can see we have added these three tools, calculator, n8n and Wikipedia. We can add more as per our requirement. Now our setup is ready. That you can see brain, our OpenAI chat model, and three tools, calculator, n8n and Wikipedia. Now let's test our workflow. So now we have to click here, open chat. Ask, tell me today's date and time. Let's press this. Also you can press enter. Now you can see here. And here this particular tool has been used to answer this particular question that you can see. Current date and time. Let's try another one. What is 45 multiplied by 18? Look at here. You can see OpenAI chat. This time direct answer from OpenAI. Calculator has not been used. Means our LLM will decide whether to use these particular tools or not. Ask this particular question. You can see here. For this large multiplication, GPT used this particular tool. And here is the final answer that you can see. Right? Now let's ask one more question. Tell me about Albert Einstein. Let's press enter. Look at here. Now you can see work been done without Wikipedia. LLM will decide whether to use these tools or not. Now let's ask this particular question. Summarize the latest information about Chandrayaan mission. Let's press this button. Please look at here. Now you can see it is using Wikipedia, and you might notice that OpenAI is used 2 times here at the beginning and at the end as well, and in between tools. Here you can see Wikipedia has been used multiple times, right? First time this LLM used for decision making to understand the question and choose the right tool. Then the tool executes and give the results. After that, LLM is used again to convert the result into a proper human readable answer that you can see, right? That you can see here, right? So internally, what is happening? Message comes, triggers agent. Agent uses model for decision. Agent selects tool, right? And result goes back, generate the final answer. So this is not just automation. This is a system that can think, decide, and act. This is the exact idea behind Agentic AI. This is our first working example for Agentic AI. Next part will make this even more powerful. Hope all of you are clear with it, right? Let's move on.
You can see just we have configured this particular workflow using OpenAI chat model. But you might be wondering, what if I want to use a different model provider? Do I need to redesign the workflow? Do I need to recreate the AI agent? Do I need to rewrite all the prompts? Or maybe you want to try DeepSeek, test Gemini, use Queen, experiment with Llama, or you want to access multiple free models from a single place without changing your workflow. The good news is that n8n makes this extremely easy. The workflow remains exactly the same. The AI agent remains exactly the same. And the prompts remain exactly the same. In the most cases, the only thing we need to change is the model provider. That's all. Another major advantage is that OpenRouter gives us access to multiple model providers, multiple free models, and a single API for all of them. This makes it very easy to compare models, experiment with different providers, or choose the best model for your use case without redesigning the workflow every time. To demonstrate this, let's switch from OpenAI to OpenRouter. So in place of this OpenAI chat model, we are going to use OpenRouter. Just search on the Google OpenRouter. You will get this particular link, openrouter.ai. Let's click over here. You can see I already log in with my Gmail account. You can do the same, right? Just log in with your Gmail account. It may ask some question and you will get this particular screen. Let's click on Get API key. I have already created this, right? Let me create new key. You can give any name. Let me give n8n. No need to change this. No expiration. You can set as per your requirement, but I'm selecting no expiration. And let's click on create. You can see this is our API key. Let's copy this. Let's save in the particular file. Afterwards, you can't see it, right? You need to create another one, which is free. You can create any keys you want. Let's copy this key. Let's minimize this. Let's close this. Now we have this key, right? As you can see, just we have created this particular workflow. But I want to show you one thing. I have uploaded all these workflows on my GitHub that I have used throughout this course that you can see. Let's click on agent_2, this JSON file, and let's download raw file. Now let's move to n8n. Click this plus workflow personal and click on these 3 dots. You can import from URL and import from file. Just we have downloaded our JSON file of our workflow. So we have to click over here, import from file. And this is the file. Let's select and let's open. Great. You can see this way you can download any of these workflows. I have uploaded all the workflows over here that I have used throughout this course. Let's back to n8n. Now Let's delete this connection and let's remove this OpenAI chat model because now we are going to use OpenRouter. Let's click over here and search for OpenRouter chat model. Let's click over here and I already configured this account. If you are using for the first time, you have to copy and paste API key over here that just we have created using OpenRouter, right? That I have pasted here. So for me, it's working fine, right? It will show you this message, connection tested successfully. Then let's close this. And some of the models are paid and some of the models are free to use. Let's jump to OpenRouter and search for free. You can see these many models are free. You can use any. I'm going to use GPT OSS 20B free. Let's move to n8n and let's search the model, this one. Let's click over here. Let's close this. So done. Please remember, don't forget to put your API key over here. Otherwise, this flow will not work, right? Let's close this. Again, let's close this, open chat, and let's try multiply 1, 2, 3, 4, 5, 6 into 9876. Let's press enter. Great. You can see the answer. So it's working perfectly fine. You can see one of the biggest advantages of OpenRouter. You can use a single API key, gives access to multiple model providers, right? These many models are free. Switching between models takes only a few clicks that you can see. And many models can be used completely free for learning and experimentation that you can see here. Hope all of you are clear with how to use OpenRouter and how to use different free models from OpenRouter. Please make a note of this. You can continue using OpenRouter and its free models throughout the rest of the course, but I will use OpenAI in the upcoming lectures for consistency. However, the overall workflow, AI agent configuration, and concept will remain exactly the same regardless of which model provider you choose. So feel free to continue with OpenRouter and free models. Or you can follow along with me OpenAI as well. The flow will remain exactly the same. Let's move on.
So in our previous workflow, we have created our first agentic AI system that you can see on the screen. We created a flow where a message comes as input. The agent understands it. The model decides what to do. The appropriate tool is selected. And finally, we get the response that you can see here. So overall, our system was able to think, decide, and act. Now everything is working well, but there is one limitation. Every time we send a new message, it starts fresh. Let's quickly verify this. But before that, let's give proper name to this particular workflow. Agent_1. You can give any. Let's click over here on this triple dots and let's click duplicate and let's give another name, agent_2. Let's click over here, duplicate. So as I just said, everything was working well, but in this particular workflow, there is one limitation. Every time we send a new message, it starts fresh. Let's verify this. Let's tell our system regarding this. My favorite color is blue. You can see our agentic system has been started. All done. Now let's ask what is my favorite color. You can see I don't know. The agent is not able to answer correctly because it doesn't remember the previous message. So now let's improve this by adding memory. For that, here you can see memory. Let's click over here, this particular plus button. And here you can see for beginners, simple memory. Let's click over here. And these are parameters and settings, but we are keeping it as it is. First, you can see session ID. This is a unique ID for each chat. It tells the system which conversation the memory belongs to. And here you can see different options. We have selected connected chat trigger node. This connects memory with the chat. So memory works with messages coming from the trigger. Here. And here you can see session key from previous node. This means we are taking the session ID from the previous node, this node, to memory, and context window length 5, which is default. This decides how many past messages the agent remembers. And here you can see default size of context window is 5. So the agent will only remember the last 5 messages. So if your important message is older than the last 5, it can't remember it, right? We can set the context window length as per our requirement, but currently I am keeping as it is 5. Please remember, session ID identifies conversation and context length how much to remember. As simple as that. Let's press escape key. So now we are back to our workflow. Now let's open this chat, and from here we can reset the session. So now again, let's tell my favorite color is blue. Please look at here. Now memory is used. Ask what is my favorite color. You can see your favorite color is blue. Great. Now you can see our agent can remember and can give the answer correctly, that you can see here, right? But please remember, there are some limitation of this simple memory. Works only for short chats. Can forget older messages. Does not save data permanently. And here you can see other memories. Remembers for long time. Can use past data anytime. Useful for real world systems, right? So currently we are using this simple memory that you can see here. Also, if we refresh or restart the session, the agent forgets everything because now session ID has been changed. Let's ask what is my favorite color. You can see I don't know. So as I just said, if we refresh or restart the session, the agent forgets everything because this memory is temporary and not stored permanently. We will see this advanced memory in upcoming sessions, right? Just we have added this simple memory. Let's test one more time. My name is Priyank. Let's ask what is my name. You can see your name is Priyank. So we have successfully added this simple memory to our agentic AI system. So now our system can think, decide, and also remember. You can see this makes our agent more powerful and closer to a real agentic AI system. Let's refresh this. You can check different parameters and settings for this particular node by clicking on it, that you can see. That is true for each and every nodes that you can see, right? In place of entire system, we can also run particular node like this. You can see. Let's press this execute step button. You can see my name is Priyank. You can see only this particular node has been executed. Now let's execute our second node, AI agent. Let's click over here. And you can see this way you can execute particular node as per your requirement. Let's ask what is my name. You can see here. And also we can execute entire flow automatically by just sending the trigger. Here the trigger is the chat message, right? Then it will run every node as per the requirement automatically. Hope all of you are clear with this. Let's move on. So in this session, we are going to build a complete vectorization pipeline. We will take a real document from Google Drive, convert it into vectors, and store it inside Pinecone vector database. So the question is, why do we need this? Because AI means LLM cannot understand raw text directly. If we give a document as it is, the system cannot search or understand meaning properly. So we need to convert text into embeddings called numbers. These embeddings capture the meaning of the text, not just keywords. This embedding representation of the text allows us to build smart search systems, chat with documents like application, RAG-based applications. So this step is the foundation of many real-world AI systems that we are going to simulate here on n8n using Pinecone vector database or Pinecone vector store. First of all, before we move ahead and implement this vectorization pipeline that you can see on the screen, we need to have a Pinecone index where the embeddings and the chunks, means pieces of the text, can be stored. So let's move to our Pinecone account. I already logged in with my Gmail account. You can do the same. Now we have to click on this database. and indexes. Here I have already created these two indexes, but let's create new index, new pinecone index. Let's click over here, create index. We can give any name. Let me give data thinkers. And here we need to configure how embeddings will be stored. So I'm going to select this particular model, text embedding 3 small. You can choose any, right? Let's move down and you can see by default dimension is 512. Let's select 1536. This is because this model generates vectors of size 1536. So this index will act as a storage layer where both the text and its corresponding embeddings will be saved, right? So now our index is ready. So let's click here, create index, done. And also you can see no record yet because we haven't performed any task, right? That's why no records yet, but shortly you will see some records when we perform some task, right? Now this is done. Our pinecone index is ready. Let's back to n8n. And here in the workflows, let's create a new workflow. First, let's click over here and let's give some name, vector store or vectorization. Any name you can give. Now let's click over here, add first step. Here, let's search for Google Drive. Let's click over here and we have to select from these actions and download files. And in the parameters, this Google Drive account that we have already connected, file, you can select file, folder, whatever you want, but let's select file because we are going to use PDF file. I will show you it, right? Download, and here this is the content from my Google Drive. Select smartcampus.pdf that I have created just to simulate this vectorization pipeline. You can see this is the document, Smart Campus AI Assistant, knowledge base document. So this is the document, right, that I have uploaded on my Google Drive, which is connected with n8n. So this is the document that we are going to use, right? Done. Let's check it, whether it is connected and we can download this particular PDF file or not. Let's click on execute step. And also from here, we can download our file that you can see, right? The file is downloaded successfully, means n8n is connected with our Google Drive properly with this particular document. Now let's press escape. Let's move it here. If you observe, a default trigger is already added. When we click this button, execute workflow, it will trigger this particular step, download file automatically, right? So which is defaultly added by n8n. Now we have to add pinecone vector store that just we have configured, right? This one. Let's click here on this plus button, search for pinecone vector store. And here from actions, we have to select add document to vector store. We already connected this account. So select this, insert documents is okay. Pinecone index that just we have created, right? This one. We are going to select this particular index. So these many indexes are already available, but I am going to select this one that just we have created. Data thinkers. Done. I am keeping embedding batch size as it is. I think done. Let's press escape key. Now this one, embeddings. Let's click over here and search for embeddings OpenAI. Let's click over here. You can see the model is already selected. OpenAI account, which is already connected. Done. Let's press escape key. So now next step, document. Let's click over here, this plus button, and you can see default data loader. Load data from previous step in the workflow. Let's click over here. Type of data. We have binary data, right? PDF file, load all input data, and I'm keeping this automatically detect by mine type. Splitting simple, which splits every 1000 characters with a 200 character overlap, right? This overlap to make context between two chunks, but I'm selecting custom, connect a custom text splitting subnode. Let's click over here. Now let's press escape key Back to our workflow. Now let's click over here, text splitter, this plus sign, and we are going to select recursive character text splitter. This splitter split text into chunks by characters recursively, recommended for most use cases. Let's click over here, recursive character text splitter. And here by default chunk size is 1000, but let's select 500, and chunk overlap, let's select 50. So here overlap helps to keep context between the chunks, so the important meaning is not lost. Let's press escape key. Now I think all done. Let's execute our workflow by clicking on this button, execute workflow. You can see the process has been started. Done. You can see workflow executed successfully. Now let's check on Pinecone console. Let's click over here. So you can see we have created this index data thinkers, and we can see multiple chunks stored over here on Pinecone vector database, means vector store, that you can see. Each chunk contains text and its corresponding embeddings that you can see over here, right? So as you can see, we have successfully completed our vectorization pipeline. So now let's understand one more time what each node is doing. So when we press this button, execute workflow trigger node, it starts the workflow. Then Google Drive node, which downloads the smart campus file, our PDF file. Then this one, default data loader, converts file into readable text. Then our recursive character text splitter breaks text into smaller chunks. Then embeddings OpenAI converts each chunk into vectors, and our Pinecone vector store stores vectors and text into index. You can see our index. So each node performs one task, and together they convert a document into vectors and store it in Pinecone vector database, that you can see, right? So trigger, then Google Drive, then data loader, then text splitter, then embeddings, and Pinecone vector store. So this is our final flow. And this way vectorization pipeline works. And this is the foundation of building RAG systems, document search, and AI assistance, right? So we have successfully read document from Google Drive, convert it into vectors, and store it inside Pinecone vector store. Let's move on. In this section, we are going to discuss a very important concept called RAG, which stands for Retrieval Augmented Generation. It's important to understand what RAG is, why we need RAG, and how it actually works. We mainly use RAG for two situations. First, when the LLM does not know the latest information. For example, if the model was trained long ago and the user asks about something new or updated, the model cannot answer correctly because it has no recent data. Second, when we want the model to answer using our own data, like company documents, user manual, PDFs, policies, resumes, internal records, research notes, etc. The model was never trained on this private data, so it cannot respond using it, right? So in both of these situations, we need a way to supply the relevant data to the LLM at the time of questioning. But please remember, we cannot dump huge documents or entire databases into every prompt. That would be slow, costly, and inefficient, right? This is exactly where RAG becomes powerful. Let's discuss how RAG solves these problems. So RAG helps the LLM by pulling only the useful part of the data instead of everything. So here is what happens inside RAG. We take our data. It could be documents, PDFs, reports, or internal company content, or even user manual, anything. We break it down into chunks. After that, we generate embeddings for every chunk and store them in a vector store. Later, when user enters a query, we convert that query into an embedding as well. After that, we search the vector store to retrieve only the chunks related to that query entered by a user. These selected chunks are added to the prompt and sent to the LLM as context for that query. So the LLM can read the question, means query asked by the user, and the related information together. Now the LLM has the user question, means user query, plus the correct data as context, only related data with that query that we retrieve from the vector store. So it produces a much more accurate answer, which is given back to the user. In simple words, we can say RAG retrieves the right information, adds it to the prompt as a context, send it to the LLM, and the LLM gives a better response. As simple as that, right? The question is why this matters. So please remember, if you consider the scenario without RAG, the LLM mostly guesses based on what it was trained on. With RAG, the LLM answers using real, up-to-date, and the relevant data. This is how, using RAG, we allow LLM to answer from our personal knowledge base, company internal files, user manual, or updated information. Hope all of you are clear with how RAG works. Now let's implement RAG using n8n. As we discussed earlier, normally when we ask a question to the LLM, it answers based on what it already knows. But if the question is related to our own document, the model does not have that information. So instead of letting the AI guess, we first retrieve the correct data and then we generate the answer. This is exactly what RAG does. Before building RAG from scratch using n8n, as you know, we already completed the vectorization process that you can see on the screen. We took the document, this particular document, right? Smart Campus AI Assistant. We took this particular document, used data loader and converted it into text. Then we split the text into chunks using this recursive character text splitter. After that, we converted those chunks into embeddings using OpenAI embedding model and store them into Pinecone vector store that you can see. So now our document is stored in the form of embeddings inside our vector database, Pinecone vector database that you can see here. As I just said, we are using the OpenAI embeddings model with Pinecone. So this is our vector store. Now we will use this data to answer user questions. Now let's understand the RAG. Then we will implement it from scratch using n8n. So you can see, we start with chat trigger. This is where the user asks a question. Then the question goes to AI agent. This is the controller. It understands the question and decides what to do. Inside the agent, we have OpenAI chat model. This is the brain that generates the answer. Now the important part, our Pinecone vector store. This allows the agent to search inside our document, which is already available on our vector store. Pinecone uses the OpenAI embeddings model to convert the query, means the question asked by the user, into a vector and compare it with the stored embeddings of our document, right? Which is available on our Pinecone vector store. Now, what's happened internally? When we ask a question, the chat trigger receives it. The agent processes the question. The agent decides to use Pinecone vector store. The question is also converted into an embeddings. Pinecone compares it with stored embeddings. Relevant chunks are retrieved. These chunks are sent back to the AI agent. This agent. The agent combines the retrieved context from our document with the question and sends it to the model, this OpenAI chat model, and the model generates the final answer. So here the model is used 2 times. First for reasoning and second for generating the final answer. Let's open the chat. Let's ask the question. You can see it is using Pinecone vector store. And this is the answer. You can see what emergency contact numbers are provided for campus security, medical center, and transport. And this is the answer. And this answer is not coming from the model's general knowledge. It is coming directly from our document that you can see here. Compare this answer with our document that you can see here. Great, right? This way RAG works. Now let's build this flow using n8n from scratch, step by step. Now let's create new workflow. Let's change the name to reg new. Let's click over here. Add first step. Let's search for AI agent. We are keeping default parameters and settings. Let's press escape key. Let's click over here. AI agent, and from add option, let's add system message. I have already created the system message. Let's copy this. Let's move to n8n and let's paste it over here. This is the system message or a system prompt. You are a retrieval based assistant. Answer the user's question using only the provided context. And these are the rules. Use only the retrieved context to answer. Do not use any prior or general knowledge. If the answer is not present, reply exactly I don't know based on the provided data. Do not guess, infer, or add extra information. Combine multiple contexts pieces carefully if needed. Do not mention sources, databases, embeddings, or internal steps. Keep the answer clear, factual, and limited to one sentence. Right? So this is our system prompt that I have provided over here to our AI agent. Let's press escape key. Now let's click over here, this plus sign. We are going to add OpenAI chat model. Let's search for OpenAI. Let's click over here. OpenAI chat model. And as you know, we are using GPT-5 mini. Let's press escape key. Now let's click over here. This particular plus sign. We are going to add tool. Means Pinecone vector store. Click over here. Search for Pinecone vector store. I have already configured this particular account, Pinecone account, that I'm linking over here, and retrieve documents as tool for AI agent. Let's click over here. Let's write some description. Work with vector store. Let's choose our Pinecone index reg demo. This one, right? Where our document is available in embeddings form that you can see here. And this is our Pinecone index that I have used over here. I think done. Let's press escape key. Done. Let's add embedding model. Search for OpenAI, and this is embeddings OpenAI. I'm using my own credential, and this is the model. Text embedding 3 small. Let's press escape key. Done. Let's press open chat. Again, here I have created some questions. Again, I'm using the same question. You can see now it is using our Pinecone vector store and this embedding model. Done and great. And you can see this answer is from our document that you can see here. So to summarize, we build a complete RAG system where our document is first converted into embeddings and stored in Pinecone, our vector store. When user asks a question, it is also converted into an embeddings using this model, right? Pinecone finds the most relevant parts of the document from here. Those parts are sent to the AI agent. The agent combines the retrieved context from our document with the question which is asked by the user and sends it to the model. In our case, OpenAI chat model. The model generates the final answer based on that data, right? This is the exact idea behind RAG, retrieval augmented generation. So instead of guessing, the LLM is now answering based on our own document. This is how we can implement RAG using n8n to build intelligent systems that answer based on our own data, based on our own private document. Hope all of you are clear with RAG. Let's move on. In this video, we are going to build and implement MCP using n8n. But before we directly start building it practically, let's first understand a few very important concepts like what is MCP, why MCP is needed, what are tools, how AI agents use these tools, difference between systems with MCP and without MCP, how MCP manages these tools, MCP architecture and how MCP works internally. Because once these concepts become clear, implementing MCP inside n8n becomes much easier and much more interesting to understand. So let's understand this with a simple real-world example. Suppose there is a senior employee in a company. This employee is very intelligent. He understands instructions, can analyze problems, and can make decisions. But even after having all this intelligence without access to company systems and tools, he still cannot actually perform work, right? For example, if you ask him, check today's sales report, he needs to access to database, Excel sheets, and internal softwares. Or if you say, send meeting emails and schedule a call, he needs to access to email systems, calendar applications, and company tools, right? So even though the employee is intelligent, without tools, he can mostly only talk. He cannot actually perform actions. Same as earlier AI systems. So earlier AI models mostly generate answers, means only can talk. You ask a question, the AI responds. And that was pretty much the entire interaction, means these interactions are limited to text generation only. Employee without tools that only can talk can't perform actions, but modern AI systems are changing rapidly. Today, AI agents can use tools, access APIs, read files, search databases, work with applications, and perform actions automatically. And this is where agentic AI becomes really powerful, because now AI is not just generating text. AI can actually interact with systems and perform the task. Before we start discussing what is MCP, let's first understand what are tools. So tools are functionalities that AI agents can use to perform tasks. There are many such ready-made tools are available. We can also create our own custom tools. So here you can see list of already created tools, ready-made tools, like calculator tool, Wikipedia tool, Google Drive tool, database tool, and API tool. There are many such ready-made tools are available. So instead of only generating text, AI agents can now perform real-world actions using these tools. And this is where modern AI systems become truly powerful, because now AI is not limited to conversation only, not limited to talk only. AI can interact with external systems and actually perform tasks. So now let's discuss what problems started after tools were introduced. Initially, connecting a few tools was easy. But as AI systems became larger and more advanced, things slowly started becoming complicated. Because now multiple agents needs the same tools, multiple workflows needed the same integrations, and different applications needed access to the same resources. Then what will happen? That's why gradually everything became difficult to manage, because every tool had different integrations, different connection methods, and different configurations. Now let's imagine we want to build systems with 10 different AI agents, and every agent needs same tools, same APIs, and same resources again and again. So without standardization, we repeatedly reconnect tools, rewrite integrations, and reconfigure setups, and very quickly managing everything becomes messy, that you can see here. So without MCP, the architecture usually looks like this, that you can see one agent connected with many tools. So AI agent has calculator tool, same AI agent has Wikipedia tool, same AI agent has Google Drive tool. For small systems, this setup works perfectly fine. But as systems grow larger, this approach becomes difficult to scale and maintain, because the tools are tightly connected to individual agents. This is exactly where MCP becomes important. So here you can see, let's start discussing MCP, Model Context Protocol. MCP was first introduced by Anthropic, and today it has become one of the most important concepts in modern agentic AI systems. In simple words, we can say MCP, Model Context Protocol, provides a standardized way for AI systems to connect with tools and external systems. This is why MCP is often called USB-C for AI applications. Just like USB-C standardized device connections, MCP standardizes AI to tool communication. So instead of directly attaching tools to every AI agent like this, MCP exposes tools through an MCP server. Then AI agents connect to those tools using an MCP client. Don't you worry, we will discuss entire architecture shortly. So here you can see system with MCP. So now the architecture becomes AI agent which is connected to MCP client connected with MCP server, and MCP server has many tools that you can see. And this changes everything because now multiple agents can reuse the same tools. Multiple applications can share integrations and tools become reusable and standardized. Means here tools are exposed through MCP servers only that you can see here. Now let's discuss very important part, how MCP helps managing tools. And now this is one of the most important parts to understand. Once tools are introduced into AI systems, the AI model needs to understand which tools are available, what each tool does, when a tool should be used, what inputs the tool requires, and how responses should be handled. And managing all this manually becomes difficult as systems grow. This is where MCP helps. The MCP server exposes information about available tools. For example, tool name, tool description, capabilities, and required parameters. Then the MCP client communicates this information to the AI agent. Now the AI model can intelligently decide which tool should be used for a particular task. For example, here is the task. If user asks what is 1234 multiplied by 9876, the AI model understands this task requires the calculator tool. So now let's first discuss MCP communication flow. Then we will discuss MCP architecture. So here you can see step by step MCP communication flow. First, AI agent receives user question as we discussed like this. Assume that this is the question. MCP client connects to MCP server. MCP server exposes available tool information. Tool performs the task. Response comes back through MCP. And finally, AI generates the final answer for the user. AI means LLM, right? So please remember here the important part. MCP is not the tool itself. MCP is the bridge between AI and tools. Tools still perform the actual work. MCP just standardizes how they connect, right? So MCP is managing and standardizing how tools are exposed and used, not performing the task itself. To performing the task, still we require different tools. Please remember this, right? The tools still perform the actual work. Hope all of you are clear with this, right? If not, it will be clear shortly when we will discuss MCP architecture. And also at the end, we will take this complete example with help of MCP. Let's move on. Understand how MCP works. First, we have to discuss MCP architecture that you can see here. MCP mainly works using three important components that you can see here: MCP host, MCP client, and MCP server. So let's start with MCP host. The MCP host is the main AI application where the agent runs. And here you can see different examples of MCP host: Cloud Desktop, VS Code, AI applications, and it may be n8n workflows. So these are MCP host. Now let's discuss MCP client. The MCP client acts like a connector between the AI application, means MCP host, and the MCP server. Its responsibilities include sending requests, receiving responses, and handling communication properly. So we can say MCP client, which is the bridge between MCP host and MCP server. Now let's discuss MCP server. The MCP server exposes tools, resources, and prompts, right? So when a client connects, MCP server tells the client which tools are available that we already discussed right? Here, right? So as I said, when a client connects, the MCP server tells the client which tools are available. Then the AI agent can use those tools whenever required. So here you can see simple MCP flow. AI agent to MCP client to MCP server, and MCP server has many tools, right? So let's take very simple example to clear this particular MCP architecture. So suppose user asks what is 12345 into 8976. So first AI agent receives the question. Don't you worry, it will be cleared 100% when we will implement and build MCP using n8n. Just listen this carefully. First, AI agent receives the question. Second, agent decides calculator tool is used as per this question asked by the user. Now, MCP client connects to MCP server. Now, MCP server exposes calculator tool. Now, calculator tool performs the calculation of this question and response come back through MCP. And finally, agent generates the final answer for the user, right? So this is the complete flow. Now here you can see some of the benefits of using MCP. First, standardization. One protocol for all AI to tool connections. No more custom integrations per agent required. Second, reusability. Tools built once, reused across multiple agents and applications seamlessly, right? That you can understand through this architecture. Agent to MCP client to MCP server. MCP server has many tools. Next, easier integrations, right? It provides plug and play approach, connect new tools to MCP server, which is very easy. All agents can access, right? Any new tools are introduced, we have to connect through MCP server only, right? Shared tool ecosystems, sure, a whole ecosystem, shared tools, multiple apps collaborate on the same resources, and it provides better scalability, scale agentic AI systems without multiplying integrations or connection complexity, right? Because we have to change here only, MCP server only, right? This is exactly why MCP has become such an important concept in modern agentic AI systems. Hope all of you are clear with this, right? Now let's implement and build MCP using n8n. Let's jump to n8n. Now that we have understood the concept of MCP, right? Let's finally implement MCP practically using n8n. Before building MCP, let's first understand the workflow that we already created earlier that you can see here. Previously, our architecture was very simple. We had chat client, AI agent, OpenAI chat model, and tools directly connected to AI agent that you can see here. For example, calculator tool, Wikipedia tool, datetime tool that we have used earlier. So earlier, the flow was user, agent, direct tools, right? User, agent, direct tools, and final response. This means whenever the user asks a question, the AI agent received the question, the agent decided which tool should be used, the tool executed the task, the response returned to the agent, and the agent generated the final answer. This was the flow, right? And honestly, for small workflows, this setup works perfectly fine. But now imagine we are building large agentic AI systems where multiple agents need the same tools, multiple workflows use the same integrations, and different AI applications need to access the same tools. Then directly attaching tools again and again like this becomes difficult to manage, right? And this is exactly where MCP becomes useful. So now here you can see workflow with MCP that we are going to implement. Instead of directly connecting tools to the agent, MCP moves these tools under an MCP server. Then the AI agent accesses those tools using MCP client. So earlier, AI agent directly connected with tools. Now you can see the flow with MCP. AI agent, MCP client, MCP server, and tools. This is the most important thing to understand. These tools are no longer directly attached to the AI agent. Instead, they are exposed through the MCP server that you can see here. Now let's build this system from scratch. Now let's click over here, workflow and personal workflow. Let's give the name to this workflow, MCP demo. Now let's click over here. Let's search for AI agent. Let's press escape button. Done. Move here. So this agent acts as the controller of our workflow. Whenever the user asks a question, the AI agent receives it first and then it decides which tool should be used, what action should be performed, and how the final answer should be generated. So you can think of the AI agent as the brain of our entire workflow. Now let's click over here, chat model. And let's search for OpenAI chat model, right? I'm using OpenAI account and I'm using this model. You can use any, right? These many models are available, but I'm using GPT-5 mini. Done. Let's press escape key. So this is our OpenAI chat model. This model helps the agent understand the question, decide which tool should be used, and generate the final answer. Now first, let's connect some tools directly to the AI agent. Calculator tool, let's press escape. Date time tool, let's press escape. These parameters are okay for us. Add Wikipedia tool. Again, default parameters are okay for us. Done. So you can see at this stage, our architecture is still the old architecture, meaning AI agent and direct tools. And this is important because now we will transform this setup into MCP architecture. Before that, let's try to run this. Multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. You can see now it has used this calculator tool and this is the answer, right? This is our old setup. Tools are directly connected, right? Now let's click this plus button and search for MCP server trigger. For now, these default settings are perfectly fine. Let's press escape key. Let's move here. So what is MCP server trigger? The MCP server trigger exposes tools through MCP protocol. Instead of directly attaching tools to the AI agent like this, we move these tools under the MCP server. You can think of the MCP server like a central provider of tools. It exposes those tools to external AI systems. Now let's move these tools to MCP server. Move this here. Let's connect to this. Let's delete this. Let's connect over here. Let's remove this and let's move here. Done. So you can see now all these tools are exposed through the MCP server only. So now the architecture changes from AI agent, which is directly connected to tools. Now we have AI agent. Shortly we will add MCP client, then MCP server, and then tools. The core transformation happening in MCP. Now let's open MCP server trigger. And you can see paste URL and production URL. In this demo, we are going to use the production URL because I found some problem while using paste URL. So let's copy this URL. Let's press escape key. Now let's click over here, tool, and let's search for MCP client tool. And here you can see endpoint. We have to paste the copied production URL, right? Means MCP server as the endpoint. Done. This tells the MCP client connect to this MCP server, this particular MCP server using production URL. Now we have to choose this HTTP streamable, and this is deprecated, right? So let's use this. We not required any authentication. And at this time, let's use all tools. So this HTTP streamable defines how communication happens between the MCP client and the MCP server. And we have chosen this, no authentication, right? So what happens internally now? Now the AI agent no longer directly accesses the tools. Instead, you can see agent uses MCP client. MCP client connects to MCP server. MCP server exposes available tools. Agent uses those tools through MCP protocol. And this is the real power of MCP, because now multiple agents can reuse the same MCP server and its tools. Now let's test MCP workflow. Let's open chat. Let's perform multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. Great. That I want to show you, right? Error in subnode MCP client. Please remember, we are using this production URL, right? So we have to publish this workflow. Then only we can use production URL. This is very important. That I want to show you. So let's press publish. Let's keep this version name as it is. And let's press publish. Escape key. Done. Right? Now again, let's try this. Multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. And great. You can see now it's working fine. And this is the answer, right? Great. Ask one more question. What is the current date and time? Now you can see chat message received to AI agent, to MCP client, to MCP server, and this particular tool has been used. Great, right? So you can understand the internal flow. Chat trigger receives the question. AI agent processes the question. AI agent uses MCP client. MCP client connects to MCP server. MCP server exposes these tools. Agent selects the required tool. Tool executes the task. Response returns through MCP client, and agent generates the final answer, right? And this is the MCP flow. Now again, let's ask what is 1, 2, 3, 4, 5, 6 into 9, 8, 7, 6. Great. Here you can see. Now the agent automatically selects the calculator tool through the MCP server and generates the answer that you can see here. So you can also test other tools like Wikipedia tool that we have used, date time tool that also we have used, and any other MCP tools. Now the one main point. Let's click here on MCP client, and here you can see we have already selected this all tools. Right? Suppose you do not want the agent to access all tools. So here we can select this selected, right? And here, as per your requirement, you can provide Wikipedia or date time or calculator, right? Only selected tools. Now agent can only use those selected tools only. Hope all of you are clear with this, right? You can try this. So as you can see earlier, tools were directly attached to the AI agent that you can see. Now with MCP, tools are exposed through MCP servers and accessed using MCP clients. This provides reusability, standardization, easier integrations, shared tool ecosystems, and better scalability. Hope all of you are clear with this, right? How MCP works. So you can see this is exactly why MCP is becoming such an important concept in modern agentic AI systems. Hope all of you are clear with this, right? Let's move on. In this video, we are going to discuss human in the loop, also known as HITL. We are going to discuss what is human in the loop, why human in the loop is important in AI workflows, different human in the loop patterns, real world examples of human in the loop, also human approval workflows, and finally, we will build a complete AI flight booking assistant using n8n with human in the loop. So if you watch this video till the end, you will get a strong understanding of human in the loop and how it is implemented in real AI workflows. So now let's first understand what human in the loop actually means. Human in the loop is a workflow pattern where an AI agent poses during execution and asks for human input, approval, or decision making before continuing further. This idea is very simple. AI can automate tasks very quickly, right? But humans still stay evolved in important parts of the workflow. Human in the loop becomes important because modern AI agents can send emails automatically, generate reports, call APIs and services, fill forms automatically, and automate complete workflows. But AI is not always perfect. Sometimes it may generate incorrect information, misunderstand the context, or take the wrong action. That's why human in the loop works like a safety checkpoint between AI and the final action. Now let's understand some common human in the loop use cases. The first one is accept or reject. For example, suppose an AI agent creates a summary of an internal company report and wants to send it to stakeholders through email. Before the email is sent, the workflow pauses for human review. A manager can approve the summary or reject it or ask for changes. If approved, the email is sent automatically. If rejected, the AI agent can generate a better summary and try again. The second pattern is human selection. In some workflows, the AI agent may generate multiple possible options. For example, imagine an AI travel assistant planning a business trip. The AI may suggest different flight options, multiple hotels, and several meeting schedules. Instead of letting the AI make the final decision, the human selects the best option before moving to the next step. The third pattern is feedback when AI is uncertain. For this, a chatbot is a very good example. Normally, the chatbot answers customer questions automatically using its knowledge, right? But if the AI is not confident about a particular question, the workflow is handed over to a human support person. The human then answers the question or resolves the issue manually. So AI handles the common questions while humans handle difficult situations. The fourth pattern is review and edit. Suppose an AI system is extracting information from Aadhaar cards, licenses, or other documents to automatically fill a form. If some fields are unclear or extracted incorrectly, the workflow pauses for human review. The human can manually correct the information and then continue the workflow. So overall, human in the loop combines the speed of AI with the judgment and control of humans. That is human in the loop. That's why human in the loop becoming an important part of modern AI systems and AI workflows. Now we are going to implement human in the loop by building an AI flight booking assistant using n8n, where user input travel request. AI searches flight options. Here, in the third step, we will implement HITL, human in the loop. Human selects means approve or reject the options given by the AI. If approve, AI confirms and books the flight. That we are going to build and implement now. Let's jump to n8n. So you can see currently I'm using n8n. So let's click over here, this plus sign, workflow and personal. Let's give it a name, HITL Flight Booking Assistant. Done. Now let's click over here, add first step. Let's search for AI agent. Here default parameters are okay for now. Let's close this. Let's move here. Now here we are going to use a system prompt. So again we have to click here on AI agent. Now click add option. Here you can see many options are available. Let's select this first one, system message. You can see by default this message is already provided. You are a helpful assistant. But I have created better one that you can see. You are an AI flight booking assistant supporting users with travel booking. The user will provide travel details such as source city, destination city, budget, and sometimes prefer travel time. Your task is to these many tasks. Also I have provided constraints. Also I have provided some guidelines and output requirements. Let's select this. Let's copy this. And let's paste it over here. This is our system prompt. Let's close this. and back to our workflow. Now first we are going to add chat model. So we have to click over here, this plus sign, and let's select OpenAI chat model. Let's select my account and I'm using this model GPT-5 mini. Let's close this. And here is the memory. We do not need memory now. Now let's click over here, tools, and let's search for Sheets, Google Sheets, which is our database. So let's click over here. I have already connected it with my Google Sheets. So that's why it is showing content from my Google Drive. Let's select this dataset, flight. I will show you it shortly. And from sheet 1. And this is our flight dataset, also called as database. You can see flight, from, to, with price, time, number of seats available, and booking email. So this is our database. Here, booking email, I have provided my email everywhere, right? For testing purpose. So this is our database. Let's back to our workflow. Done. Let's close this. So now we have this chat model and also our database. Let's test this. So let's open chat and let's type, I want to travel from Ahmedabad to Delhi under 6,000 rupees. Let's press enter. You can see processing has been started. Done. You can see the agent uses the model, reads the row from our Google Sheets, means from our database, and selects the best matching flight. Done. You can see the output is generated by the agent. Also, by clicking over here on AI agent, we can see the output. Right now, this output is very clumsy, right? It contains email, subject, body, and all other information together. But later, we cannot map this easily to our Gmail node because finally, we want to send this confirmation email to the client. That is the reason we are going to do one additional step. So let's close this. Again, let's click over here on AI agent and we are going to enable this require specific output format. Let's click over here. Once you enable it, you will see an additional option called output parser. Let's close this. And here you can see one additional option, output parser. Let's click over here. There are many output parsers are available. This is deprecated. So we have only two options and I am going to select this one, structured output parser. Please remember it's output parser, right? Return data in a defined JSON format. Let's click over here. And here you can see schema type. Two options, generate from JSON example or define using JSON schema. I'm going to use this one. And this is default input schema. But I have created nice one. This one, name, flight booking email, type object, property, booking email, which is string type, also provided description, email subject, email body. And these are required fields. Inside this schema, we are saying the output should contain this booking email, email subject, and email body. All of them are required, right? So again, Control A, Control C, and here Control A, Control V. Done. So this will create structure output that we can use further. So we want this structure output. That's why we are using structure output parser. Let's close this. Again, let's test this. Let's click over here, reuse message, and let's press enter. Oh, great. You can see the output, nicely structured output, right? We can see from here by clicking on this AI agent that you can see. Great output, right? So now you can see booking email, email subject, and email body. These are coming from the AI agent output. Let's close this. Now in the next step, we want to send an email. So let's click over here, search for Gmail, and we want to send a message. So we have to select this, send a message. And these are the parameters. I have already configured this for n8n. So let's select this and 2.
So we have to take this from output booking email, then subject, this subject, and email body, which is part of the message. Done. Email type is not HTML, it's a text. Done. From here also we can execute this step. Let's click over here. And this is my email. You can see there is no email yet. Let's refresh this. Great. You can see. Dear traveler, and this is the perfect email. But one thing that you can observe, we are getting this. The email was sent automatically with n8n. To remove this, let's back to our workflow. And we have to click over here, add option, append n8n attribution. After that, we have to disable this. Done. Again, let's execute this step. Let's refresh this. Gmail. Great. You can see now n8n information has been removed. And this is great email that you can see. Booking reference, flight, route, departure, arrival, travel class, fare and availability, baggage allowance, e-ticket and receipt will be sent to this email and warm with regards that you can see, right? Nice. Now let's back to our workflow and let's close this. Now the main part. We are going to add human in the loop. So let's disconnect this. Let's click over here, plus sign. And here you can see many options. And we have to select this human review. Again, send and wait for response. Chat, Discord, Gmail, Google Chat, and many other options. But I am selecting chat. The user will type inside chat window for approval or for rejection, right? That's why we are choosing chat. So here, let's write one message. Type approve if you want to continue with the selected flight booking. If not, type reject. Also, let's show the subject first. And let's drag and drop over here. It will show the subject, and also we want to show the body part of the email. Let's drag and drop over here. Done. So the generated subject and body will be shown directly inside the chat window. Let's close this. For this human review node to work, we need to configure one additional item in the chat trigger node. So let's click over here, our first node, and let's click over here, add field. And we have to select response mode. Using response node. Done. So please remember, once you enable this, the human review node will able to send messages back to the chat window. That's why we are doing this in the trigger node. Done. Let's close this. And let's test this. Again, let's reuse this message and let's send it one more time. You can see processing has been started. You have to wait. It will take some time. Great. You can see. As per our message, type approve if you want to continue with the selected flight booking. If not, type reject. And also here the subject and the body, right? That we have configured. So you can see this node has not been executed yet, right? It is waiting for human approval. So let's write approve. Let's press enter. Please look at here.
You can see. Now workflow executed successfully. This is called human in the loop. Hope all of you are clear with this, right? Now the main part. Now before sending the email, we need to verify whether the user typed approve or not. So for that, we have to add if node. Let's click over here, this plus button, and search for if node, this one. Also we have switch node, right? Let's use if. So now if chat input is equal to approve, means if the user types approve, we will send the email. Done? Let's close this. And if it is true, we are sending the email. Or false, we are doing nothing, right? If approve, we are sending the final ticket. Else, nothing. So let's test this. Again, reuse this message. Let's send. Again, we have to wait. It will take some time for the execution. That you can see. Execution is going on. It is running nodes as per the requirement. And great, you can see. It is waiting for the approval. And then it will execute this part. Let's write approve. Please look at here. You can see. Problem in the node, send a message. That you can see here, right? Error message here. So let's click over here. And we have to remove this. Also we have to remove this. And also we have to remove this. And that we are getting from here. To booking email. Let's drag and drop subject field. And email body as well. Done. Let's close this. Let's execute entire flow one more time. Again, I am reusing this message. Let's send the message. You can see. There is no any new email, right? Let's back to our flow. You can see it is executing different nodes as per the requirement. And you can see type approval, right? So we have to approve or reject. Let's assume that we are okay with this ticket and we are approving it. And you can see workflow executed successfully. Great. And this is the email that I have configured in n8n. Let's refresh this. And great. You can see the final ticket with the passenger, right? And with great information. With reservation details, important information that you can see, check-in opens 48 hours prior to departure and other information. And regards. Great. Right? So this is a complete real world example of human in the loop in n8n where AI handles automation, but humans stay in control before the final action happens. That you can see. Hope all of you are clear with HITL, human in the loop. Let's move on.
In this video, we are going to discuss guardrails in AI workflows. So here we will learn how guardrails protect AI systems, how to block unsafe requests, how to sanitize sensitive information, and how to implement guardrails using n8n with our AI flight booking workflow. By the end of this video, you will clearly understand how real AI systems add safety and control before allowing AI agents to take action. Guardrails help to protect both the AI system and the users. They add safety, security, and control to AI workflows. Usually guardrails are placed before the input reaches the AI agent or before the AI response reaches the user. Input guardrails check what users are sending into the AI system. For example, passwords, API keys, Aadhaar numbers, personal information, or unsafe text. This can be blocked before reaching to the AI agent. Output guardrails check what the AI agent is generating. They help to stop hallucinated responses, toxic content, unsafe replies, or sensitive information leakage before the response is shown to the user. In n8n, we get a dedicated guardrails node. Let me show you this. Let's jump to n8n. As you can see, currently I am on n8n, and this is the workflow that we are going to implement. As I just said, in n8n, we get a dedicated guardrails node. Let me show this. Let's click over here on this plus button and let's search for guardrails. Let's click over here. And as you can see, this node mainly works in two modes. The first mode is check text for violations that you can see. And the second mode is sanitize text that you can see over here. In this video, we are going to implement both check text for violations as well as sanitize text. So let's first discuss this mode, check text for violations. Then we will implement this sanitize text. So here, check text for violations that will stop unsafe messages before they reach to the AI agent. So we are going to implement this in our flight booking workflow that we have implemented from scratch in our last video. So let's click over here, home button, and let's click over here, our last project. And here, these three dots. And let's duplicate this. Let's give one name. Guardrails mode check text for violations. Let's click over here. Done. So let's close this original. So we have to put guardrails between this check message means trigger node and AI agent. So first let's delete this connection. Now we have to click over here, this plus button, and again let's search for guardrails. Let's click over here. So as you know, first we are going to implement this check text for violations, right? Then we will implement this sanitize text. So let's click over here, check text for violations. And here are some options. And here also you can see these two modes, right? And here text to check. That text will be received from here, from this chat window, right? To make it simple, first let's delete this node. Again, let's reconnect. Let's execute our flow. Open chat and let's write, I want to book ticket from Ahmedabad to Delhi under 6,000. Let's press enter. So this will execute our flow, and it's a human in loop, right? So it will ask for human input. We have to wait. It will take some time. Great. Here you can see, type approve if you want to continue with the selected flight booking. If not, type reject. Currently, we not require this. So let's press reject. Done. Now let's delete this and you will see the difference. Why we have executed the entire flow first. Now let's click over here, this plus, and let's search for guardrails and check text for violations. And great. You can see, we want to see this input. That's why we have executed our original flow first. So text to check for what? Chat input. Let's drag and drop over here. Now let's click over here, add guardrail. And these many options are available that you can see. Keywords, jailbreak, NSFW, personal data, secret keys, URLs, topic alignment, URLs, custom. Also, we can write our custom regular expression for this, right? So for this demo, let's use keywords, this first one. Let's press over here, keywords. And here we want to enter idiot. So now if the incoming message contains the word idiot, the guardrail will block the request. Let's close this. Done. Let's move the node over here. And this over here. Now pass out to this. When fail, we are doing nothing. Let's check. Let's open this chat window and let me write, you are an idiot. Sorry for this. This is not proper to write such words. I'm using just to demonstrate the flow with guardrails. Book a flight from Ahmedabad to Delhi. Let's press enter. Please look at here. Workflow is executed successfully up to these two nodes, not from here, right? Because let's click over here. And you can see match keywords idiot. That's why guardrail block this particular request that you can see, right? So our flow is not executed from here. Now let's press up arrow and let's remove this word idiot. Now let's press this button. Please look at here. So we have to change the mapping over here as well. We are getting from input, you can see connect chat trigger node. Now it is not connected directly with chat trigger node, right? It is connected with guardrail. So we have to change this. So let's put it over here. Because AI agent is now getting input from guardrail node, not from the trigger node, right? That's why we have to change this mapping. I think done. Let's close this. So if pass, we are sending it to AI agent. If not, if fail, we are doing nothing. Again, up arrow and we are sending normal message. Great. Now you can see. Done. Because of this, you can see it is asking for human input. We are not approving, right? Unnecessary, we not want to send any email. So I am rejecting it. But done. That you can see. You can see triggered false. So that's why it is passed over here. So now this is first example, right? Where we have used keyword. Now let's take one more example. So it will be cleared properly. Let's click over here. Guardrails node and we are keeping these keywords as it is. Let's click over here. Add guardrail. Again, many options are available. Let's click over here. Personal data. So here you can configure different types of sensitive information such as email addresses, phone numbers, passport numbers, Aadhaar numbers and more. For this demo, we are going to use email address. You can see type all and select it. As I just said, when you are selecting all, it will consider all email addresses, phone numbers, all kind of sensitive information. So let's click over here, select it, and you can see entities, many, right? That you can see credit card, crypto, date, time, and many. Indian PAN card, Indian Aadhaar card that you can see, right? So let's select email address. You can try others. Done. Let's close this. So now the guardrail will check whether the incoming message contains an email address. If an email address is detected, the workflow will stop and the message will never reach the AI agent. Now let's test it. Let's open this chat window and let's write my email address is taste@gmail.com. Book my flight Ahmedabad to Delhi under 6,000. Let's check. Let's press enter. You can see workflow executed successfully up to this node only, right? Because our message is blocked over here. Let's click over here. You can see trigger true and entity type email address. So as you can see, the guardrails node blocks the request that you can see over here because the input contains the personal information. So if you observe here properly, currently if the guardrail detects a violation, the workflow simply stops. But in the real world applications, we usually want to inform the user why the request was blocked. Now we are going to handle the fail branch properly because we have handled nicely pass branch. But now we are going to handle this fail branch as well. So let's click over here, this plus button, and let's search for chat because we want to inform the user in the chat window itself, right? So that's why I am selecting this chat. Let's select send a message. So let's write some meaningful message. Your request was blocked by the guardrails policy because it contains restricted or unsafe content. Please verify your message and try again. That we want to show in the chat window. Right? Done. Let's close this. So since we are using a respond to chat node here, let me show this. What I'm telling. You can see verify you are using a chat trigger with the response mode option set to using response nodes. So what it is telling, let's click over here, chat trigger node, and here you can see we have already set using response nodes. Without this setting, the response message from the fail branch will not appear inside the chat window. So please don't forget to do this inside the trigger node here. I think done. We are ready to test. Let's reuse this message and let's execute our workflow. You can see it is moving over here. Let's check. Great. You can see your request was blocked by the guardrails policy because it contains restricted or unsafe content. Please verify your message and try again. Great, right? Again, let's use the same, but this time I want to send a normal message. Please look at here. Now you can see this branch is executed. Pass. Now the request passes through the guardrails node and reaches the agent successfully. That you can see, right? Again, let's reject. Done. I hope all of you are clear with this, right? What is guardrails? And also we have implemented using n8n to filter unsafe or restricted input before it reaches the AI agent. Now let's understand the second guardrails mode called sanitize text. I am keeping this flow as it is that I will upload on my GitHub so you can download and test this workflow as well. So again, home, again I am taking this, our flight booking example, and let's duplicate this, guardrails, sanitize text. Let's duplicate this. Done. Let's close this original flow. So in the previous example, when the guardrail detected a violation, the workflow stopped completely, right? But sometimes we do not want to block the request. Instead, we want to clean or sanitize the unsafe content before sending it to the AI agent node. That we are going to do here. And this is exactly where we can use sanitize text mode in guardrails. So now let's implement this. But before that, let's execute this flow hook, flight Ahmedabad to Delhi. Now done. Let's delete this branch because we are going to add guardrails node here. So let's click plus here. Let's search for guardrails. And this time we are going to select the second mode, sanitize text. So now you can see, we can see this information here because just we have executed our flow once. So text to check, which is chat input. Let's click over here, add guardrail. These options are available: personal data, secret keys, URLs, and custom regular expression that we can create. Let's first select personal data and we are going to select selected only, not all. And in the entities, these many options are available. Same. Again, we are going to select this email address. Done. Let's close this. Let's connect this to agent, our AI agent. Let's test this. My email address is test@gmail.com. Book flight from Ahmedabad to Delhi. Let's send this message. Please look at here. Problem in node AI agent. We have to change the mapping because previously this chat trigger was directly connected with AI agent. Now guardrails in between. So that's why we have to change this mapping. Let's click here. In place of connected chat trigger node, we have to define as below. And input is from guardrails input. Done. Let's close this, open chat, copy this, send this. Great. Now you can see our workflow has been executed. Let's wait. Let's check. Open chat. Again, we have to write approve or reject. We don't want to send unnecessary email. So I am rejecting it. Done. Let's check this AI agent. And here you can see my email address is this. It is not showing the original email address. Because of sanitized text, it is masking the sensitive information in place of blocking it. That you can see over here. That I want to show. Right? Let's take one more example. Let's close this. Let's click over here, guardrails, and let's click here. And this time, let's select this Indian Aadhaar card. Done. So here we are sanitizing both email addresses and Aadhaar card. Let's close this. Let's test this. Let's open chat. My Aadhaar card number is 123456789123. Book a flight from Ahmedabad to Delhi. Let's press enter. Our flow is currently executing. I think all done. We are getting this approval or rejection message, but let's click over here. And you can see, I want to show you this masking. My Aadhaar card number is this. Now, if somebody accidentally enters an Aadhaar card or email address or any other personal information, the guardrail will sanitize it automatically before sending it to the AI agent that you can see here. It is not sending original Aadhaar number to AI agent, right? This is masking, or this is sanitize text. So the guardrail will hide or sanitize the Aadhaar number before the AI agent processes the request that you can see here. So you can see this is another very important real world use case of guardrails in AI workflows. So you can see now we have discussed both guardrails mode in n8n, check text for violations, and sanitize text. One blocks unsafe requests completely, the other cleans sensitive information before continuing the workflow. Hope all of you are clear with guardrails, right? Try to implement this with different examples and let me know in the comment section. See you in the next video. In this video, we are going to understand multi-agent AI systems. So here we will discuss what multi-agent systems are, why a single AI agent is sometimes not enough, how multiple AI agents collaborate together, different multiple agent patterns, and how to build a practical multi-agent workflow in n8n. By the end of this video, you will clearly understand how modern AI systems divide complex tasks across multiple specialized AI agents instead of depending on a single agent alone. Now, let us first understand what a multi-agent systems actually means. A multi-agent systems is a workflow where multiple AI agents work together to solve a particular problem. Instead of giving one AI agent every responsibility, we divide the work between specialized agents. Each agent handles a specific task. Let's take one example, flight booking system. So in a flight booking system, one agent can search flights, another agent can verify budgets, another agent can generate emails, and another agent can handle customer support. So instead of one large AI agent doing everything, we create multiple smaller specialized agents. This approach provides better accuracy, cleaner workflows, easier debugging, modular design, and better scalability. Now let us understand some common multi-agent patterns. All these patterns we are going to implement using n8n. So first pattern is sequential agents. In this approach, one agent completes a task, passes the output to the next agent, and the workflow continues step by step. This pattern is called sequential agents. Now let's understand the second pattern, which is supervisor agent. Here, one main agent acts like a manager or supervisor and delegates tasks to other specialized agents. This is our supervisor agent or supervisor pattern. Now let's discuss our third pattern, parallel agents. In this approach, multiple agents work simultaneously and their outputs are combined later. So we are going to implement these three multi-agent patterns, sequential agents, supervisor agent, and parallel agents using n8n. So let's jump to n8n. As you can see, now we are on n8n. Now let's start with our first multi-agent pattern called sequential agents. As you know, in a sequential multi-agent system, one agent completes its task first, then passes the output to the next AI agent, and the flow continues step by step. This is sequential multi-agent system. This is useful when the next task depends on the previous task output. Now let's implement a simple sequential multi-agent workflow using n8n. And for this demo, we will build AI travel planning assistant. So here, the first agent will suggest flights. The second agent will suggest hotels. And the third agent will generate a final travel summary. So for this example, we are not using any external dataset or Google Sheets because our main goal here is to understand sequential multi-agent architecture and how multiple AI agents pass information step by step inside a workflow. So now let's build this step by step, our AI travel planning assistant. So here let's give the name first, sequential multi-agent travel planner. You can download this all from my GitHub account. Link is provided in the description of this video. This plus sign, and we are going to add our first AI agent. Let's search for AI agent. And this is our flight recommendation agent. So we have renamed it. Now let's click here, add option. We are going to add system message or system prompt. Let's remove this default. I have already created this flight recommendation agent. You are a flight recommendation agent. Your job is to recommend one suitable flight, suggest a budget-friendly option, return short flight details that can be used by the next agent. Keep the response short, clean, and professional. Do not explain reasoning, right? That I have created for all three agents. So let's copy this. Let's paste it over here. Done. Let's close this. So this is our first agent. And next we have to add our chat model. OpenAI chat model. Let's skip this default parameters and let's close this. Let's run this. So this is the message. Plan a Goa trip from Mumbai under 25,000 rupees. Let's run this. So currently our first agent is running. Our flight recommendation agent is running. Done. This is the output from our first agent. Now let's click over here because we are following sequential agent. So we have to click over here and we are going to add our second agent, which is hotel recommendation agent. So first let's change the name, hotel recommendation agent. Done. Same, add option, system prompt. And this is system prompt for our hotel recommendation agent, our second agent. Let's copy, let's paste it over here. Done. But one main thing. Here you can see the connection, one after another. The input should come from the first agent output, right? So we have to change the mapping. You can see. Let's click here to our second agent. Here it is connected to chat trigger node by default, this. But here we have another agent in between. So we have to change this connection. So here two options. We have to select the second option defined below. And you can see flight recommendation agent, which is first agent. The output of this we have to put over here. That will become input to our next agent. Now done. We can directly add this chat model over here. Like this. Right? But I think let's add new chat model. Done. Again, let's use the same message. I'm pressing up arrow key. Let's run this. You can see our first agent is running. Output of this first agent become the input to the next agent. Hotel recommendation agent. Done. Also, you can check the output after two agents. Both have done their work. But now we are going to add our third AI agent, travel summary agent. Let's click over here, this plus sign, AI agent. Again, we have to change this trigger to define below. You can see. You might have observed why we are running our flow again and again. If you are not running, you can't see this output from the previous agent. So we have to run our flow at each step. Then only you will get this. Otherwise not, right? That's why we are running our flow again and again. Please remember this. Done. Add option, system message. Let's remove this. I have created for this. Let's copy, paste it over here. This will create a final summary from previous by combining flight recommendation and hotel recommendation agents output and generate the final summary. Let's give the name travel summary agent. Done. Let's close this. I think now it's visible, right? Again, here we have to add our brain. OpenAI chat model. Done. All done. Now again, open chat. Press up key and the same query from the user. Now you can see output of this first agent become the input to our second agent. which combine the both, and output of this will become input to our travel summary agent. We have to wait, it will take some time. Now you can see this is our sequential agent. Each agent receives the processed output from the previous agent, which creates a proper sequential multi-agent workflow that you can see over here. So it will take some time. I'm going to post this video. Done. So workflow executed successfully. Now let's open this chat and let's check the output. Great. You can see recommended flight, recommended hotel, and short travel summary. Great. So what happened here? The first agent recommends flights, then the second agent recommends hotels, and finally, the third agent generates the final travel summary that you can see. This is called sequential multi-agent architecture because agents execute one after another in sequence that you can see, right? So this is a simple practical example of sequential multi-agent workflows in n8n. So now let's understand another important multi-agent pattern called parallel agents. As you can see in this sequential workflow, agents executed one after another, but in parallel multi-agent systems, multiple AI agents work simultaneously. This is useful when tasks are independent and do not depend on each other's output. For example, one agent can finalize flights, another agent can analyze hotels, and another can analyze tourist attractions all at the same time. And this makes the workflow faster, more scalable, and more efficient. Now let's implement a simple parallel multi-agent workflow in n8n. So again, for this demo and for simplicity, we will again build AI travel planning agent, but this time all agents will work independently in parallel. So here, let's click this plus button, workflow and personal. Click this sign, AI agent. So this is our first agent, flight recommendation agent. Again, add option, system message, and these are the prompts, system prompts, right? Almost same as we have used for sequential agent. Let's copy this and let's paste it over here. Let's close this. Let's move here. Chat model, OpenAI chat model. We are keeping this default parameters. Let's close this. Done. Now let's create our second AI agent. This time we have to add new agent from here because we are implementing parallel agent. So let's click over here, AI agent, and this. Let's change the name. This is hotel recommendation agent. Let's close this and we have to connect this from directly chat trigger node because they are working in parallel. Let's click over here, add option, system message. Let's remove this. And this is our system message. Let's copy this. Let's paste it over here. Done. And let's use this same OpenAI chat model. You can add one separate model over here as well. Now done. Let's add our third AI agent. We have to click over here, AI agent, which is tourist place recommendation agent. Again, add option, system message. Let's remove this. Let's copy the system message. All these you will get from my GitHub account. Link is provided in the description of this video. Done. Let's close this. Again, we have to add this. And chat model I'm using same. You can add separately from here as well, right? Done. So you can see the workflow looks like this. Chat trigger connected with all. Flight agent, hotel agent, and tourist place agent. So now all these agents will be executed simultaneously instead of waiting for one another. This is called parallel multi-agent architecture because our agents will work independently in parallel. Now let's test this. Chat, and here plan a Goa trip from Mumbai under 25,000 rupees. Let's press enter. You can see we have to wait. It will take some time. You can see all these agents are executing in parallel, right? So here one agent recommends flights, one agent recommends hotels, and another recommends tourist attractions, all at the same time. So this is simple practical example of parallel multi-agent workflows in n8n. Let's check. Great. You can see plan for 4 days, estimated cost, recommended hotel, budget friendly stay. Great, that you can see, right? Hope all of you are clear with parallel multi-agent workflows. And let's understand another very important multi-agent pattern called manager or supervisor agent architecture. In the previous sequential workflow, agents were connected step by step manually, right? In this parallel workflows, agents work independently at the same time. But in the real world AI systems, we often use one main AI agent that controls multiple specialized AI agents. This is the main agent, and this main agent is called manager agent or supervisor agent. The supervisor agent acts like a team manager. Instead of manually deciding which agent should execute and when it should execute, the supervisor agent makes those decisions dynamically. This architecture is very common in enterprise AI systems, AI copilots, autonomous AI agents, and customer support systems. Also in research agents. Now let's implement a simple supervisor multi-agent workflow in n8n. For this demo, we will build AI student admission assistant. So here the supervisor agent receives the student request first and then delegates tasks to specialized agents. We will create marks verification agent, document verification agent, and admission summary agent. Now let's build this step by step. So let's create new workflow and let's call it supervisor multi-agent admission system. Now let's click over here, AI agent, and this is our supervisor agent or manager, right? So we have to give system prompt accordingly because this is a manager. System message, and you can see system prompt for supervisor. You are a supervisor agent. Your job is to understand the student admission request, coordinate specialized agents, assign marks verification, assign document verification, and generate a final structured summary. Assume all required student documents are already uploaded, right? That we are assuming for this task. To make it simple, keep the response short, professional, and structured. Do not explain reasoning. So let's copy this prompt and let's paste it over here. Done for supervisor agent, our main manager agent. Let's close this. Let's move over here. Now the main part, we have to add here next AI agent as a tool, right? So we have to click over here, this tool, and you can see AI agent tool. Great. So we have to use this. We are keeping this description as it is. And here, let's change the name, marks verification agent. Add system message. And this is very simple prompt for marks verification agent. Done. Let's close this. And we have to add the chat model first. OpenAI chat model. Let's keep parameters as it is. And this agent is also using this. You can add separate model here as well, but I am using this common chat model. Let me check it once. Student Rahul has scored 85% in HSC. Documents uploaded, Aadhaar card, mark sheets. Check admission eligibility. You can see it is using OpenAI chat model multiple times. You can see workflow is executed successfully. Let's check, and this is the result. right? But here you can see this issues. Parameter prompt user message is required. Let's click over here and here. Let the model define this parameter. Done. Let's close this and I'm refreshing it. As you can see, we have added one supervisor agent and marks verification agent. Now let's add one more agent, document verification agent. So again, we have to click over here. Please remember this, right? Tool of supervisor agent and AI agent tool. Let's change name to document verification agent. Let's click over here. Let the model define this parameter. Add option, system prompt or system message. And this is the system prompt for document verification agent. Let's copy this. Let's paste it over here. Done. Again, I am using this same chat model. Now let's add one more agent for admission summary agent. Again, we have to click over here, supervisor agent, AI agent tool, and let's change name to admission summary agent. Again, let the model define this parameter. Add option, system message. Let's remove this default. And this is admission summary agent. You can see you are an admission summary agent. Your job is to combine verification results and generate a final admission summary. Keep the response short, professional, and easy to read. Copy this and let's paste it over here. Done. Again, I am using same chat model. As I said multiple times, you can use separate chat model as well. You can see now supervisor agent is connected with marks verification agent, document verification agent, and admission summary agent. So now the supervisor agent controls the workflow and delegates tasks to specialized AI agents dynamically. This is called supervisor multi-agent architecture because one main agent manages multiple specialized agents. So before I execute this, you have to understand very important thing. How this workflow actually executes internally. When the user sends a request, shortly we will send, the supervisor agent receives the request first. Then the supervisor agent decides which tool agent should execute. So internally it calls the marks verification agent tool, receives the verification result, then calls the document verification agent tool, receives the document verification result, and finally calls the admission summary agent tool. It may be in different order as well. That supervisor agent will decide how to call, when to call. The final summary is then written back to the user. So unlike sequential workflows, we are not manually connecting agents step by step. Instead, the supervisor agent dynamically controls the execution flow. So now let's test this. So let's open chat and this is our prompt. Student Rahul has scored 82% in HSC. Documents uploaded, Aadhaar card and marksheet. Check admission eligibility. Let's enter this message and you can see now supervisor agent will decide which agent to be called. So here the supervisor agent analyzes the request, delegates marks checking to the marks verification agent, delegates document checking to the document verification agent, and the finally admission summary agent generates the final admission result. And great, you can see the final summary. Great, right? So this is a simple practical example of supervisor multi-agent workflows in n8n. Hope all of you are clear with multi-agent AI systems. So we have successfully implemented these three multi-agent systems: sequential agents, supervisor agent, and parallel agents. Hope all of you are clear with this, right? Try to implement this by your own and let me know in the chat window. See you in the next video. This is very important session. Watch up to the end. I am sure you will learn something. Let's assume that we have deployed our AI flight booking agent in a real business environment. Users are continuously sending booking requests, travel queries, approval requests, and email confirmations. Everything seems to be working perfectly. Bookings are being generated, emails are being sent, users are getting responses. But here is the real question. How do we know the AI is actually working correctly every single time? What if one day the AI generates the wrong booking email, hallucinates flight information, sends incorrect pricing, produces inconsistent responses, or behaves differently for similar user queries? And what if this happens while dealing with real customers, bookings, payments, approvals, or business operations? Even a small AI mistake can affect user trust, create business issues, or trigger incorrect automated actions. Right? So before deploying AI systems at scale, we need a way to continuously verify, is the generated email correct? Is the subject line correct? Is the response format correct? Is the AI behaving consistently? Is the workflow producing the expected output? And that is exactly why evaluations or evals become extremely important in AI systems. So in this session, we are going to implement evaluations or evals in n8n. Before we start the practical, let's first understand what we are going to build. As you know, this is our normal workflow that you can see on the screen. Before we move ahead, let's execute this once. Book a flight from Ahmedabad to Delhi under 6,000 rupees. You can see this is our normal production workflow that handles user query, moving to guardrails, then after to AI agent, then after approval and email sending, right? Let's wait. Now let's open check and here you can see approval. So now let's approve this. We are okay with this ticket. Done. Look at here. We will get a confirmation email. Great, right? That you can see here. This is our normal workflow, right? That just we have executed. With this normal workflow, we are going to add an evaluation workflow that looks like this. Don't you worry, we will implement this from scratch. So here the dataset input, then guardrails, then AI agent, then evaluator, then correctness score that we are going to implement. So instead of real users provide inputs that just we have done, we will use an evaluation dataset. And instead of sending emails, we will generate evaluation scores. To build this evaluation workflow, we are going to perform 3 simple steps. Step 1. In this step, we will add the evaluation trigger. And we will connect this evaluation trigger with our dataset and feed dataset inputs into the existing workflow. In the step number 2, we will add the check if evaluation node, this one. We will configure the set metrics node like this. Also, we will define the expected output and capture the actual output generated by the AI agent here and compare both using an LLM. In the step number 3, we will run and analyze evaluations. Let's click over here. So in this step, we will execute the evaluation and review correctness scores that you can see here and inspect individual runs and identify areas where the AI agent can be improved. So now that we understand the overall process, let's start with step number 1 from scratch. The objective of this step is very simple. We want to create an evaluation trigger. We want to connect our evaluation dataset and feed dataset inputs into the existing workflow. So this is our normal existing workflow. Now let's click here, these triple dots, and let's duplicate this flow eval and let's close our original workflow, right? As I just said, we are going to implement evaluation workflow with this existing workflow. So let's click over here and search for evaluation. And first we are going to add triggers on new evaluation event. And we have to give here one dataset, which is expected output that I have created using Google Sheets. So let's click over here. Then this is the sheet name, flight underscore eval underscore dataset, and sheet containing dataset, which is sheet number 1. And this is the dataset that I have created for expected output. You can see if user input like this. So this is expected email. This is expected subject and this is expected body. Such 3 rows I have created. You can create multiple for the evaluation. For the teaching learning purpose, I have created only 3 rows like this, right? This is our expected output done that I have attached over here. To fetch here inside n8n, let's execute the step. So actually, this is our starting point of our evaluation workflow. Done. Here is our data set. You can see. Let's close this. Let's put it over here and let's connect it with our guardrails. So as I just said, this is starting point of our evaluation workflow. So as you can see earlier, guardrails were receiving input from chat messages, which is entered by the user. But during evaluations, input should come from the data set, right? This data set. So let's click over here because now we have to add the mapping. So with this chat input, also we have to receive input from our data set as well. Done. So mapping is done. Now guardrails receiving input either from chat input from the user or from the dataset. So done. So please remember, whenever an evaluation runs, guardrails will receive input from the dataset instead of a real user message. Not from here, right? From here only. When we execute evaluations. So we can say our step 1 is complete. Now let's move to step number 2. Configure the evaluation logic. So the main purpose of this step number 2 is to identify when the workflow is running as an evaluation. We want to compare expected and actual outputs, and we want to calculate evaluation scores automatically. That's why we are going to do this step number 2. So as you know, AI agent which is connected with chat response, right? But now we have combined two workflows together. One is normal and one is for evaluation. So here we have to add one node, evaluation, and check if evaluating, right? Let's close this. We are good with default parameters, not here, but here. Let's remove this connection and we have to give over here. If normal, then it is connected with chat response. If our evaluation workflow is running, then here we have to add the set matrix. And let's keep this metric as it is. These are the possibilities of the matrix that we can use, but we are checking for the correctness. So we are selecting this matrix. Now the main part, expected answer. The expected answer from our dataset when fetching a dataset row. Input, then expected email, then expected subject, and expected body, which is our expected answer available inside our dataset, right? This one. Now actual answer, which is generated from AI node here, which is not available that we want. So let's close this and let's execute our AI agent once. Then only we will get actual output. Done. So now let's click here in the evaluation. So we have done with expected answer from our dataset. Now the actual answer from AI agent that we want to compare. Again, actual email which is generated by AI agent, email subject, and email body. Done. So this is our expected answer and actual answer generated from AI agent. Let's close this. And also here we required model to evaluate this actual output with expected output. So we are connecting this evaluation step with this OpenAI chat model. I think done. So we are fetching a dataset row one by one. Then if evaluation, go to matrix. If normal, go to response chat, and we are moving accordingly, right? Done with step number 1 and step number 2. Now step number 3, run and analyze evaluations. So here you can see 3 tabs: editor, executions, and evaluations. So let's click over here, evaluations. Let's click over here, run evaluation. You can see here, status running. We have to wait. It will take some time, right? So it will take some time. We have to wait. I'm going to pause this video and it's done. You can see completion tokens, prompt tokens, total tokens, execution time, and correctness score. Let's click over here to check individual run for our 3 rows. from our data set, right? One by one, that you can see. Here you can see for row number 1, we are getting score, correctness score is equal to 3. For second, 2. And for third, 2 as well. And here it is showing prompt tokens, completion tokens, total tokens, and execution time as well, that you can see. And this is average correctness score for this evaluation for our 3 inputs. So the correctness score is usually between 1 and 5. We can say that 1 is equal to poor, 2 is equal to fair, 3 is equal to good, 4 is equal to very good, and 5 is excellent. Higher score means the generated output is closer to the expected output that we are expecting in our data set. In our case, you can see the workflow received a correctness score 3 and 2. So now currently, I don't focus too much on the score itself. The purpose of this practical is to understand how evaluations work, how to configure them, and how to execute them, and how to analyze the results, right? That we are doing here. So in the real world project, if you receive a lower score like 1, 2, or 3, that simply indicates there is a room for improvement. Here our score is not poor, but it is indicating there is a room for improvement. You can improve the score by refining the prompts, improving workflow logic, making expected outputs more consistent, improving dataset quality, or using a different model. This is exactly why evaluations are valuable. So instead of guessing whatever the AI is performing well, we now have the measurable feedback that helps us continuously improve the workflow. The important thing is that the evaluation pipeline is working correctly. The workflow is being tested automatically, that you can see. And we now have a mechanism to measure and improve AI performance over time, that you can see here, right? So this is our evaluation pipeline. Let's close this and let's move back to editor. So this is our evaluation pipeline that we have connected with our normal pipeline, right? So when we perform these evaluations, this evaluation pipeline will be executed. But when user open the chat and write the query like book of light from Ahmedabad to Delhi under 6,000 rupees, it will execute our normal workflow that you can see here, right? So we have 2 workflows. You can execute this automatically when you want to perform evaluation, and normal workflow by opening this chat window. You can see, right? If you are okay with this, then write approve. Otherwise, reject. Let's approve this. Done. Because of this, we have received this final confirmation email. So now we have these 2 workflows, one normal workflow and one evaluation workflow. Hope all of you are clear with this, right? Let's move on. Now we are going to discuss one important thing. When we ran the evaluations earlier, that you can see here, we could see correctness score, prompt tokens, completion tokens, total tokens, and execution time. But one important thing was missing. We could not easily see which input was used, what output was generated by the AI agent. This all we want to see here. With all this, it would be much more useful if we could see both the input and the generated output directly inside the evaluation results over here. So let's configure this. Let's go back to our editor. Let's execute this step first. As you know, why we are executing this first? Because we can easily get mapping that we want, right? We have to wait. It will take some time. So I think done. So here, let's delete this connection. And here, let's search for evaluation. And here we have to set inputs. Let's set the name of this node to inputs. Add input, name, input, and value that we are getting as expected email. You can add more, but I am currently using only expected email that we want to show in the evaluation table. Done. Let's close this. So you can see this all we can see because just we have executed our workflow. So let's close this. And now we have to connect it again to our guardrails. Now input is done. Next, we want to capture the output generated by the AI agent. So now let's remove this. And let's click over here. Again, evaluation, and now we have to set outputs because we want to capture the output generated by the AI agent. So again, set outputs and Google Sheets. Also, we are going to add different actual fields over here as well in this particular sheet as well. So Google Sheets, our account, our flight eval dataset, this. So it will also add actual outputs over here as well. And sheet 1, add output, name, we have to take it from here. Email, the name that we want to see in the evaluation sheet, actual email. Let's drag and drop over here. Actual subject. You can see that we are getting from AI agent. Then actual body. Done. So this actual email, actual subject, and actual body will be added over here as well in our original dataset in this Excel sheet. And also you will see in the evaluation table as well. Let's close this. Now don't forget to connect it back to the evaluation matrix. I think done. Let's move to evaluations. Now also you will see the change in this graph. Now run test. I already executed it 2 times. So this is third run for me. It will take some time. We have to wait. I'm going to post this video. Now you can see status completed, completion tokens, prompt tokens, total tokens, execution time, and correctness, which is increased, right? Let's click over here. This is latest evaluation run. And great, you can see. Now you can see additional columns are added. Input, actual email, actual subject, and actual body that you can see, right? And this is extremely useful because now we can see what input was tested, what response the AI generated, and how the generated output compares with the expected output that you can see here, right? These fields, actual underscore email, actual underscore subject, and actual underscore body are generated from our AI agent that we can directly compare with this dataset. And also here you can notice actual email, actual subject, and actual body contents are added over here as well in our original dataset, right? That you can see. Great. So also you can expand any row and inspect the complete details that you can see for this particular run. This makes it much easier to understand, right? Why a score is high, why a score is low, and what improvements can be made to the workflow. As you keep running evaluations, the dashboard will also maintain the history of runs and allowing you to compare performance across multiple evaluation runs as well, right? That you can see here, our multiple runs. I hope all of you are clear with how to perform evaluations of our AI workflows. Let's move on.